theorem. This is very important one, and this theorem states that let fz be continuous in a domain D, and if integral of fz dz over C equal to 0 along every simple closed contour C contained in that domain, then fz is analytic in that domain. Analytic means the derivative of the function exists at all points of the domain D, right? And it is given to us that fz is a continuous function in a domain D, and this integral over C is equal to 0 along every simple closed contour. So please look it over here, figure 1. This is your domain D, and let's fix point z0 inside this domain, and the value of the function fz is equal to, I'm taking integral f of xi d xi from z0 to this z, right? This is independent of the path of integration from z0 to z, fine, and this lies inside D. Okay, let's choose a small h enough in absolute value so that the line segment from z to z plus h, considering this h to be very small enough in absolute value, so that the line segment from z to z plus h lies in domain D. And because I need to reach f dash z equal to f of z, so for that I'm considering this f of z plus h minus f of z divided by h. Let's consider this. So this is equal to, by this definition, f of z plus h becomes integral from z0 to, yes, if I'm having z over here, so the end point should also be z, and the starting point should be z0, right? So if I'm having z plus h over here, so the integral will be from z0 to z plus h f of xi d xi, right? Minus f of z is integral from z0 to z f of xi d xi, and it is also divided by h, right? Okay, so this is further equal to 1 over h integral from z0 to z plus h f of xi d xi minus, if I interchange these limits from z to z0, then this integral becomes negative, right? F of xi d xi, and then managing this negative as positive. And now in the next step, writing this integral first. So this is 1 over h integral z to z0 f of xi d xi plus integral from z0 to z plus h. I need to merge these integrals together. So this is equal to 1 over h. Okay, so the integral from z to z0 and then from z0 to z plus h. So this becomes, by merging these together, this becomes integral from z to, yes, z plus h. Very fine. F of xi d xi, right? Okay. Then if I take the absolute value of this f of z plus h minus f of z over h and taking its difference with f of z, then this will become mod of, yes, what is the value for this? It is 1 over h integral from z to z plus h f of xi d xi minus f of z, and then this is 1 over h integral from z to z plus h f of xi d xi. Please look it over here. If I integrate this f of z with the limits z and z plus h, right, d xi, then this value becomes f of z into xi from z to z plus h. So that is equal to f of z, putting the limits, this is z plus h minus z. So this becomes z cancelled out. So this is h into f of z, right? So can I write in place of fz as this integral divided by h? So writing this as 1 over h integral from z to z plus h f of z d psi. Is it clear? Okay. And now taking 1 over h common and merging these two integrals together, we get integral from z to z plus h, and this is f of psi minus f of z d psi, right? Now this mod is further less than equal to 1 over absolute value of h into integral from z to z plus h mod of f of psi minus f of z into mod of d psi. And by the continuity of fz, for every epsilon positive, we have this mod to be less than, strictly less than epsilon. So by continuity of fz, for every epsilon positive, we have this mod to be strictly less than epsilon for mod h sufficiently small. So this complete mod is now having the sign strictly less than because of this mod, right? So this is 1 over mod h integral from z to z plus h, and mod of f psi minus fz is epsilon, and here we have mod of d psi. So this is further equal to 1 over mod h, taking epsilon outside and solving this integral, we get mod of h. So this will cancel out, that will gives us epsilon. So this complete mod is strictly less than epsilon. Thus, this complete mod is strictly less than epsilon for mod h sufficiently small, right? But this epsilon was arbitrary, therefore limit h tends to 0, f of z plus h minus f of z divided by h is equal to f of z. Thus, fz is analytic in D with f dash z is equal to f of z. Because we have to prove that derivative of this fz exists at all the points in D, so moreover, by Cauchy's integral formula, fz must have derivatives of all orders. So if we get the result as first derivative of this capital Fz is equal to f of z, then second derivative of this capital Fz will be equal to first derivative of this Fz. So in particular, the second derivative of capital Fz is equal to first derivative of Fz at all points in D. Thus, this f dash z exists at all points in D, and hence fz is analytic in D. Hence proof. Thank you. Stay blessed.